And we are looking at the sun on 193 angstroms here. Large coronal hole swinging into the Earth-facing zone. Let's check out another view. And here's your local yellow dwarf at 171 angstroms. This is about 7.5 hours of solar activity, which is very low, by the way. 10.7 centimeter radial flux, still at 67 solar minimum conditions. And we're going to look at a whole bunch of other data here, but first, I would invite you to check out the video we shot yesterday. Actually, we recorded it 2 days ago, and yesterday got it fully uploaded. It's a 40-minute long-form conversation with David Dubine of Adapt 2030. Here's a teaser.
And we got all these Chinese banks underwater that are definitely connected in Hong Kong, and then Hong Kong's connected way back out into everything else internationally. So is it really organically happening, or is this an engineered thing, smoke and mirrors show on?
Anyway, check out that video, youtube.com/smAsho, and also help support our channel on Patreon, as we've had 2 more videos, at least one of which was manually reviewed and put on limited monetization. Since YouTube pays us nothing, we don't particularly care, so thanks, patrons. Again, check out patreon.com/smAsho. If you become a patron, you will see some material before everybody else does. You can also donate via PayPal, or you could purchase CBDs via the Hemp Lucid Spaced Out campaign, specifically formulated for our spaced out viewers. Buy yourself some CBDs, increase your health, improve your life, help support the channel. We appreciate it. Here's the last 24 hours of solar wind data, and we see oddities in the solar wind density creating big spikes in the magnetosphere movies. We'll show you in a minute. Current solar wind density at 8.98, but we've seen spikes at a density over 100 on the instrument there, and it looks like we are settling into a 180-degree phi angle here, folks. That coronal hole is magnetically connecting as I speak. Solar wind speed 348 kilometers per second. Here's the ACE data, which is looking pretty similar. Where are all those high-density spikes coming from? That's the question you should be asking yourself. And the answer is they appear to be coming from the solar wind, but overall activity is pretty weak, so it's pretty weird. Again, 10.7 centimeter radial flux at solar minimum conditions, 67 solar flux units. Next, we are seeing some major compression in the magnetosphere movies here, as those high-density solar wind spikes keep coming in. Especially at the end of the movie, you're going to see a major spike around 8:25 UTC. Extreme compression there, especially on the leading edge, what we would call the bow shock, where the solar wind contacts the magnetosphere. I'm going to rock that back for a minute. Extreme compression event right there, where the high-density plasma is right on the edge, right there. Extreme compression right in that zone. 8:22 UTC. And this does equate to global current. We're going to look at the ground geospace magnetic perturbations in a moment. First, we'll show you the pressure movie, and you're going to see an extreme pressure event at that same moment according to the University of Michigan geospace model. Once again, these spikes coming in right as I do show prep. There's that final one at 8:25 or so, 8:22. As the plasma bounces off. We'll pause it right there. There's that extreme pressure and the effects of it magnetohydrodynamically speaking. Here's a geospace ground magnetic perturbations. And you're going to see further evidence that ground magnetometers are turning on at the same time as we see these magnetosphere shocks. And there's the one we were looking at We're going to pause that. Again, right around 8:23. Here it's at 8:24. And we'll view it at the poles also. Here's a view from the poles. This is 4 hours of data on this and the last slide, folks. Again, it's the University of Michigan Geospace model, which is based on the Space Weather Modeling Framework. Just click the links below the video if you want to see what that entails. Scroll down, click details, and you can read all about the Space Weather Modeling Framework. Let's put this in the spot where that shock occurs. As you see, obvious Birkeland currents passing through your planet. Center of this one is located over Antarctica, right near the coast. And on the north, it's actually at the geomagnetic North Pole net, not at the Siberian pole or the Canadian pole. It's in between them. Note the spiral shape of these areas. Again, Birkeland currents. KP is at 1, having just come down from 2. And here's the F2 ionosphere movie. This is the last 6 hours of the ionosphere. And there's the latest image. Looking pretty normal from that view. GOES X-ray flux has been totally flatlined since July 7th. Electron flux looking pretty smooth. Here's the LASCO C2, the LASCO C3, that is. And this data finally updated on the Space Weather Enthusiast dashboard. It looks like the GOES X-ray imager works normally again too now, and for that we thank you. There's the GOES magnetometer data, still looking pretty spiky, and next we'll move on to the GONG 2. Here's the GONG 2 images. This is 2 hours and 30 minutes old. We see some activity kicking off on the far side of the sun here, so that's something to watch. You see the fields kind of battling for supremacy there. Let me bring us to the last frame. Again, we do see activity rising here in the east, about halfway between stereo A and the Earth. So it's something to watch. Something to watch in terms of fields, and yeah, we're going to continue to see spikiness in that GOES magnetometer until this situation smooths out. So magnetohydrodynamics are very difficult to predict, and this is one of the few ways that we can do so. Here's where the planets are in the solar system. Milky Way galaxy team for the win. And there's where they'll be in 1 week. Here's what's going on above my head right now. The moon right near its apex, Mercury just rising. Enough said about that. in-the-sky.org. Sky Map 2 is what we're using here. Feel free to put in your own location and set up your own star map. Check out the largest citizen science project in the world, the Galaxy Zoo project. The Zooniverse.org project, Galaxy Zoo, where we need citizen scientists to classify galaxies. Sadly, you're not classifying this obvious quasar here. You're doing this one. And will you be the citizen scientist to classify this galaxy? Again, Zooniverse.org's Galaxy Zoo project. This plug brought to you at great personal expense by me. Earthquake rundown includes, in the last 24 hours, we see 4.9 at India, a 5.4 at Papua New Guinea, a 4.6 at Chile. Western South America should remain on alert for a larger quake. 4.1 at Afghanistan, that one's at depth. I remember warning last week about a larger quake at Afghanistan. This one's at 97.7 kilometers depth. 5.4 magnitude at the Western Indian Antarctic Ridge, just south of Australia, followed by a 6.0 in that same location. A pretty large quake down there south of Australia. 5.0 at Afghanistan. There's that larger quake at the surface, expressing quickly this time. 4.2 at Japan, that one's at over 400 kilometers depth, heads up there for a larger quake. 4.9 at Papua New Guinea. 4.9 at the Chagos Archipelago region. 4.3 on Kamchatka. And a 4.3 at Peru. That's another deep quake. Again, heads up Western South America. We are having an extreme 7 magnitude earthquake drought. and those always end in earthquakes. Here are the pressure maps on windy.com. We'll advance that one day. If you've got deep earthquakes happening below your feet, and you've got an anomalous low pressure system approaching, I would know which buildings were going to fall down outside if I tried to evacuate, and so should you. Have an earthquake plan. Be an asset, not a liability, in the event of a disaster. Next is the volcano rundown. Karimsky on the Kamchatka Peninsula is exploding, producing a 20,000-foot ash plume. Mount Aso, not sure if it's going off or not, as it mustn't be visible in satellite imagery. Mount Ibu back on the list, exploding with a continuous volcanic ash emission. Sanjiang Api, that's an 8,000-foot ash plume at Mount Ibu, by the way. Sanjiang Api, 10,000-foot ash plume there. Krakatau exploding again, producing a 3,000-foot ash plume. While comparatively small, please do not attempt to pole vault over Krakatau. It's a bit dangerous. Tucona, producing a 6,000-foot volcanic ash plume there. And a Tongan earthquake, a Tongan volcano here, unnamed, comes out in a weekly report from the Smithsonian GVP. So that's a new one there on the list. Also, Popocatépetl producing a 19,000-foot ash plume and exploding, as well as Sabancaya exploding in a 24,000-foot ash plume. Don't Fosbury flop over Sabancaya. Here are the jet streams in the Western world. Convective forces playing havoc in the Northern Hemisphere, and extreme meridional jet stream flow in the Southern Hemisphere. Let's flip it to the Eastern world. Again, convective forces playing havoc with the northern jet stream, as it barely resembles a jet stream. And doubled up extreme meridional flow in the south is putting hot air where it doesn't seem to belong and cold air where it doesn't seem to belong, etc. That's what causes it, by the way, and it's not carbon dioxide. Here's a U.S. Doppler radar, courtesy AccuWeather.com. We see a long string of storms stretching all the way from Lake Erie to northeastern New Mexico. We'll look at it in the water vapor map next. And there's the water vapor map. You can see these two strips of dry massive air, this being cold dry massive air and this being just dry massive air, shuttling this moisture in place, creating sort of an atmospheric river situation. And it's kind of stalled right now, and it's all got to do with this dry air holding all of this moisture in place. So that's why it's all in this same convergence line, folks. And let's do a quick zoom in over Indiana. There's that convergence zone there. I would note in this area, look at all the Hall streamer currents. All of these lines here where water is lining up perpendicular to the mode of motion as electric current and electromagnetic fields run the weather, not mankind. Today we're going to put the that is an ass and that is a hole in the ground section in the video and probably get this video demonetized by YouTube also. Hey, thanks YouTube for the manual review. Obviously you don't understand the distinction between your ass and a hole in the ground. Were you aware that Google is a company that will transcribe your YouTube videos and attempt to apply algorithms to censor you? We cover Google scams regularly on our channel, so watch our older videos. Were you aware that fame is a liability and not an asset? Hey kids, you want to get famous on YouTube? Why don't you just get rich on YouTube and be a hermit? It's way better than being famous. You want to get recognized in public? Really? Really? No, you don't. You don't want to get recognized in public. You might think you do. I'm here to tell you that it sucks. Let's define some terms as we usually do. Cosmology, which it references as a branch of metaphysics. I thought it was a branch of astronomy, but whatever. Anyway, it's a branch of astronomy that deals with the origin, structure, and space-time relationships of the universe. And we try not to use too much science mumbo-jumbo on the channel. since astrophysics is being rewritten during this neo-renaissance, let's talk about a quasar. Quasar is a special type of galaxy which looks super bright and produces an extremely large amount of radiation. We could call it active galactic nucleus, massive radio sources, etc. Let's talk about a great PDF document that we've linked underneath the video, which explains a lot about cosmology that people don't quite understand. So these active galactic nuclei, these typically look like this. M87 is part of this same structure. Everybody's so familiar with the black hole, the quote, black hole, end quote. We're not going to get into that too much, but if you want to read about active galactic nuclei and radio galaxies and quasars and blazars and so on, read this PDF document. It's quite amazing. It's 80 pages long, and I read it in bed this morning. So yeah, check out this PDF. It's super good. Again, links in the description. Click on them after becoming our latest patron. Also, check us out on Facebook, facebook.com/smAsho. We're also on Gab. We're also on Twitter. We're also on Minds. And even on Instagram. Believe it or not, if you want to see the more behind-the-scenes, non-space weather-related stuff, check us out there. But especially check out Minds, minds.com/smAsho, the future of social media. It's open source. It won't censor you. It won't shadow ban you. Get us to 478,000. Get us to 500,000 views. And thanks to our latest 3 subscribers. Cheers. That's about all I've got today, folks. We are out of here. Thanks for tuning in, Smash Team. We will be returning to doing Smash streams, by the way. But before we leave, one more bonus feature. Gotta have the 304 angstroms view. We're going to zoom in on these filaments on the south, and then we are going to exit stage left, Huckleberry Hound way. Is it Huckleberry Hound? I always get those Hanna-Barbera characters mixed up. Anyway, there's those filaments on the southeast, 304 angstroms. We also have one on the northwest. Thanks again for tuning in, everybody. Please don't forget to like and subscribe. And visit the links below the video in the description. Help to support the channel. Thanks, donors. Thanks, new subscribers, etc. Remember, when you're staring at the sun, don't drink. And if you drink, stare at the sun anyway. Just don't drive. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your veins.